This video is reviewing the problems that I assigned you on page 167 in preparation for the major assessment that is, of course, due Monday. I'm just going to go through each problem one at a time, and I will flip over to my calculator at various points. I've already pre-entered the data, so I won't have to spend the time inputting it for two of the problems, but let's get started. With number 27, your economics instructor assigns your class to investigate factors associated with GDP of nations. Each student examines a different factor for a few countries and reports to the class. Apparently, some of your classmates don't understand STAT very well because you know several of their conclusions are incorrect. Explain the mistakes in their statements below. Statement A. My very low correlation of negative 0.772 shows that there's almost no association between GDP and infant mortality rate. In reality, correlation can be measured between -1 and +1. So the closer it is to either end, the stronger it is. So a negative 0.772 is actually fairly strong. So that's an incorrect statement. There actually is a fairly strong negative linear association. Part B, there's a correlation of 0.44 between GDP and continent. That statement is completely off the wall crazy because continent is not a quantitative piece of data. Continent is categorical data. Thus, a correlation would not even be feasible for a problem like that. Going to number 28. Same situation. Explain the mistakes that they made. There's a very strong correlation of 1.22. I'm going to stop you right there. Correlation can only be measured between -1 and +1. Clearly a mistake. Part B. The correlation between literacy rate and GDP was 0.83. This shows that countries wanting to increase their standard of living should invest heavily in education. Correlation, which this thing has, it has a fairly strong correlation. Correlation does not mean causation. Just simply put. The guy is saying that if you want to increase your standard of living, you should invest heavily in education. You don't know that for sure. There could be some other reason why the two are correlated together. Storks do not bring babies. I've mentioned that in the past. I don't think I've mentioned it in regards to our lessons recently, but you can have a strong correlation between the number of storks increasing and the number of babies being born, but that does not mean that one caused the other. Number 29. A researcher studies children in elementary school and finds a strong positive linear association between height and reading scores. The taller you are, the better the reading score you get. Okay. Does this mean that taller children are generally better readers? Well, you can't say that being taller causes you to be a better reader. You cannot say that whatsoever. But yes, taller children are correlated with higher reading scores. You just cannot say that one causes the other. Just because somebody's taller doesn't mean they're better at reading. What might explain this strong correlation? Well, the taller you are in children's ages, I should say in elementary school, the taller you are generally relates to the grade level that you are in. The taller you are generally relates to the age that you are. That should really be it, though. One could say that age is a lurking variable. That's just the terminology behind it. I'm going to jump to number 38, which I have already inputted the data for this. I just wanted to read this before I jump to the next thing. A survey was conducted in the United States and 10 countries of Western Europe to determine the percentage of teenagers who had used marijuana and other drugs. Ooh, bad. The results are summarized in the table, and I'm going to flip over to the next page so we can see it. There it is. Percent who have used, the country that they're from, marijuana versus other drugs. It says to create a scatter plot, which I have already done. I've inputted my data. I've turned on my plot. Zoom 9 it. Here is what the scatter plot would look like for number 38. Now, seemingly, yeah, it looks pretty straight to me. I ran, actually, just for the sake of argument, I ran a linreg on this thing. I already turned my diagnostics on. And you can see, yeah, it has a pretty strong R value as well. Pretty strong correlation coefficient. Yay, happy day. But let's read what the questions are saying. It says create a scatter plot. And as I said in my directions, I didn't require you to draw one because they're kind of time sucks, for the lack of a better term. But you could create it on the graphic calculator and screenshot it if you wanted to. That's up to you. Part B. What is the correlation between the percent of teens who have used marijuana and the percent who have used other drugs? Well, as we showed you right here, it should be 0.934. You have to make sure that you input your information correctly and run that LINREG diagnostics on. Part C. Write a brief description of the association. Now, as I said in the directions, looking at this, as I said in the directions, if you're going to describe an association, you're going to have to describe direction, which in this case is positive, form, which seems linear. Yeah, I would say it's linear. Direction, form, strength. It's pretty strong. It's fairly strong, considering the correlation coefficient. It's very close to 1, so I'd say it's very strong, to say the least. Fairly and moderate would be a little bit lower, but this is very strong. And if there are any outliers, and there do not appear to be any outliers. I'll read you exactly what the textbook answer key says. It says there's a strong positive linear relation between the percent of teens using marijuana and the percent of teens using other drugs. In general, in countries with higher marijuana use, there tends to be higher use of other drugs. They're not saying that one causes the other. They're not saying that. They're just saying that, yeah, these two things are correlated with each other. There tends to be a relationship between them. D. Do these results confirm that marijuana is a gateway drug? That is, that marijuana use leads to the use of other drugs? No. You can't say that based on this correlation. Correlation does not mean causation. There might be other reasons. There might be a lurking variable that we are unaware of. So you cannot say that one causes the other. You can just say that, well, yeah, marijuana users also tend to use other drugs more, but you can't say that one causes the other. Very distinct verbiage there. Number 42. The Minnesota Department of Transportation hoped that they could measure the weights of big trucks without actually stopping the vehicles by using a newly developed weight in motion scale, whatever that is. To see if the new device was accurate, they conducted a calibration test. They weighed several stopped trucks and assumed that this weight was correct. Then they weighed the trucks again while they were moving to see how well the new scale could estimate the actual weight. Their data was given in the following table. Now, I'll flip my thing over here. I actually entered my data into list 3 and 4. You can see that there. So I'm going to have to change this to L3 and L4 in order to actually look at the scatter plot. This is the scatter plot for that particular problem. And just for the sake of argument, I'm going to run a LINREG, but because I'm not using L1 and L2, I actually have to use L3 and L4 there in order to get this to run correctly. Japan. And there's my information there, but I haven't even read what the question's asking. So let's go back to that. Make a scatter plot for these data. Okay, make a scatter plot for these data. There it is. Again, that seems very linear to me. I haven't even read the rest of the questions, but it seems very linear. I know that eventually maybe they'll have you describe it, the association between them. But yeah. Part B. Oh, there it is. Describe the direction, form, and strength. Direction, positive. Form, linear. Strength, very, very strong. And in regards to the strength, of course, you can reference the R value, but also the fact that the points are very closely clustering around where that line of best fit would be. Part C. Write a few sentences telling what the plot says about the data. Note, the sentences should be about weighing trucks, not about scatter plots. Now, that note, just as a side note, is in reference to context. When you're writing these sentences, they expect you to have context. Context. Let me just read for you exactly what the book says, just to kind of bypass any of this stuff. This is exactly what the back of the book says. the new scale is able to predict the static weight fairly well, except possibly at the high end. The reason why they're saying that is just because it seems a little bit more scattered apart up top, but that extra little note is not necessary. It may be possible to predict the static weight. Let me repeat that because this is the fluffy language. It may be possible to predict the static weight from the new scale accurately enough to be useful, but the weigh in motion measurements seem a bit too high. If I were to actually create, let me do something here. Let me throw this into my y equals key. There it is right there. Let me graph it just to kind of see what that line of best fit looks like. It's not too bad. See, in reality, the way that I would answer that, that's what the back of the book says, but the way that I would answer it, write a few sentences telling what the plot says about the data. Okay? Well, what does this plot say about the data? It seems to me that static weight and the in-motion weight, or the weight in motion, seem to be linearly associated with each other. Positive. I mean, obviously, I already mentioned the positive linear earlier. But yeah, this seems to be pretty accurate. It seems to be that this new weight in motion, was that what they called it? The weight in motion station? Scale, whatever. This new weight in motion scale seems to be pretty accurate in capturing what the actual static weight of the truck is. Something along those lines, something very simple. D, find the correlation. Well, they're referring to the numerical value of the correlation, which we already found earlier. It was 0.965. E, if the trucks were weighed in kilograms, how would this change the correlation? Now, there was a note about correlation, which basically stated that changes in scale would not change the correlation coefficient. 1 kilogram is equal to 2.2 pounds. These are measured in thousands of pounds, of course, or something along those lines. So if 1 kilogram is 2.2 pounds, if I were to divide each of these by 2.2, watch this. I'm going to totally wait. Let me see what the last question is. The point is deviate from the overall pattern. Yeah, we'll talk about that in a minute. But let me show you something here. I'm going to go into here, and I'm going to change L3. I'll go to L5 to do it. And I'll say take L3 and divide it by 2.2. So we're changing the number of pounds. Boom, now it's in kilograms. And then we'll go here and we'll do L4 divided by 2.2. And I'm changing it into kilograms. Cool. So now I'm going to run the linreg, but instead of L3, L4, I'm going to change it to L5, L6. Now, the thing that you got to keep in mind is it may change the line of best fit. It may change the line of best fit. You can see right there, it was originally, 0.637 and then 10.8? Boom, 0.637, and now a new y-intercept. A new y-intercept. It has the same slope, which makes sense because all you did was divide all the data points by 2.2, and you calculate the slope by taking r times the fraction standard deviation of y over standard deviation of x. Just saying. It doesn't change the r value, clearly. But yeah, that's what it comes down to. The correlation would not change. You don't have to do that calculation to do so, being that you're changing the scale. R is not affected or not changed by a change in scale. Part F. Do any points deviate from the overall pattern? What does the plot say about a possible recalibration of the weight in motion scale? Again, just to bypass everything, I'm just going to read to you what the back of the book says. At the higher end of the weigh in scale, there is one point where the weight in motion is much higher than the static weight. The line does not seem to go through the points where x and y are equal. The new scale may have to be recalibrated. Let me go back to this. I'm actually going to rerun this thing with L3 and L4. Boom. Stored it, graphed it. There it is right there. Oh, you can't see it. There it is. Yeah, I guess you could say that, you know. 'Cause, again, the question was, do any of the points deviate from the overall pattern? I mean, some of them kind of do. Like the ones in the middle seem to be a bit lower, but then the one at the very far end right there, for some reason, that one's a bit farther away. The deviation, or the residual, I should say, seems to be a bit more up here than it does for the rest of the points. I mean, the argument could be made that perhaps the heavier the truck, um, the more inaccurate it becomes. I don't know. I don't have enough evidence to support that. It's just one of those fluffy language things where you could potentially speak to something like that. Because that's what they're really looking for. They're just like, hey, are there any way that we can improve this? Well, yeah, of course there's ways you can improve this. Clearly, not all the points line up perfectly. You're not going to get all the points to line up perfectly, but you hope to get them as close as possible. If you have any questions in regards to the problems that I just reviewed with you, by all means, please email me. And of course, your major is due on Monday. Goodbye.